So in this video, we're going to talk about how to multiply a polynomial by a monomial. So what we're going to do is we're going to use a distributive property. And remember, that tells us what to do when we're multiplying an expression by a factor. So every term within the expression gets multiplied by the factor that we have. So for example, if we're doing 4 times x minus 3, the 4 will multiply x and the 4 will multiply 3. So we have 4x minus 12. So also we need to combine like terms. So when we have our final expression after we do all our multiplying, sometimes we'll see some terms that we can go ahead and combine. Remember, like terms are terms that have the same variables raised to the same exponents, and you can combine them by combining their coefficients. So what I like to do in this process is I like to rearrange the expression I have so that the like terms are written together. So for example, if I have 6x squared plus 3x plus 2y minus 2x plus 3x squared plus 5y, I went ahead and color-coded my like terms. And then I rewrote this expression so that my like terms were written together. Whenever you're rewriting, you want to be careful and make sure that the sign that's in front of the term in the original expression stays with it. So like, for example, when I move this 2x around, I'm going to keep that minus sign in front of it. So when I rewrote it, I got 6x squared plus 3x squared, and then I have 3x minus 2x and 2y plus 5y. So notice that every term that's like color-coded for being like terms have the same variables and the same exponents. And then we can combine those terms by combining the coefficients. So like 6 plus 3 gives us 9x squared. 3 minus 2 gives us 1x, which we can just write as x. And 2 plus 5 gives us 7y. So let's go ahead and now multiply a polynomial by a monomial. So what we're going to do is we're going to take the monomial and distribute it to every term in our polynomial. Then we'll multiply each term and remember to work with the coefficients separately from the variables. Then we'll use the product rule of exponents, which tells us that we add the exponents together, and we'll combine like terms to simplify whenever possible. So let's, for example, try multiplying 3x times 2x cubed minus 5x plus 3. So I'm going to take that 3x and I'm going to distribute it to every term that's in that second expression. So let's go ahead now and do that. So I have 3x times 2x cubed, so I'm going to write that first. And then we have minus, and we have 3x times 5x. And then we have a plus, and we have 3x times 3. Okay, so now I'm going to rearrange each of these terms a little bit so you can see that I'm going to work with the coefficients separately from the variables, right? So we have 3 times 2 and then x times x cubed. And then that's something that we discussed in that multiplying monomials lesson, right? So we have 3 times 5 and then x times x. And then the last term we have 3 times 3 and then we have our x. So 3 times 2 gives us 6. Remember, x by itself is an x to the 1, so I'm going to add my exponents, which gives me x to the 4th. Minus 3 times 5, which is 15. X times x is x to the 1 and x to the 1, so when I add them together, I get x squared. Plus 3 times 3, which is 9, and then I have x. So when you're multiplying these, you may not need to write out all of these extra steps. And if you don't need to, that's fine. I'm just doing that in this video so you can see where I'm getting these terms from. So now let's try this problem. We have x squared times x squared plus 3x minus 2. So I'm going to start off by distributing this x squared to all of these terms. So I have x squared times x squared plus x squared times 3x minus x squared times 2. So let's now rearrange whatever we can. So we have x squared times x squared, plus here I'm going to pull out that 3, and then we have x squared times x, which is basically x to the 1, and then minus 2 times x squared. Okay, so x squared times x squared, I'm going to go ahead and add those exponents and get x to the 4th, plus 3, and then we have 2 plus 1, so x to the 3, and then minus 2x squared. Okay, so that's the simplified expression. So now you can go ahead and pause the video and try doing this example on your own. So here we're distributing 8x squared. So we have 8 times 3 and then x squared times x squared. So we have 24x to the 4th. And then we have 8x squared times 2x. So that's going to become 8 times 2 and then x squared times x. So the 16x cubed. and then 8x squared times 5. So 8x squared times 5 will become 8 times 5, and then x squared, so 40x squared. I want to show you how we can put this all together. So this problem will actually combine what we did just now with distributing monomials to polynomials and what we did with addition of polynomials. So like first, remember when we do order of operations, we do the multiplication first. So I'm going to start off by distributing this 5x here in this first polynomial. So I have 5x times 2x squared minus 5x times 3x plus 5x times 4. Okay, and then I'm going to distribute in my second. So I have 3 times 7x minus 3 times 8. Okay, so 5x times 2x squared is going to be 10x cubed minus, and then we have 5x times 3x, so that's going to be 15x squared. And then plus 5x times 4 is going to be 20x. So all of that, we're going to think of that as our first polynomial. And then we're going to do our second polynomial, which is going to be 3 times 7x, which is 21x, minus 3 times 8, which is 24. So now it's just like an addition of polynomials problem, right? And remember what we were doing is we were writing the polynomials in standard form and then adding in our missing terms with like zeros. So for example, this first polynomial I'd rewrite as 10x cubed minus 15x squared plus 20x plus 0, right? Because there's no constant term. The second polynomial, I'm going to have to add in zeros because there's no x cubed term and there's no x squared term. But it does have an x term, so I'm going to write 21x and then minus 24. And then we can go ahead and combine our like terms. So 10x cubed plus 0 is 10x cubed. Minus 15x squared plus 0 is minus 15x squared. And then 20 plus 21 is going to give me 41x. And then 0 minus 24 is just going to be minus 24. So see, you can combine several different ideas in one problem, right? So we can do our distribution and then we can do the addition of polynomials. So to multiply a polynomial by a monomial, distribute the monomial to every term in the polynomial. Remember to use the product rule when you're multiplying variables with exponents.